Now time for infinite sums after this terrible joke. A bus carrying an infinite number of people arrives at a bar, and the first person gets off the bus and says, "I'll have a pint, please." And the second person says, "I'll have half a pint, please." The third person says, "I'll have a quarter of a pint, please." The fourth person says, "I'll have an eighth of a pint, please." And the barman, who was a mathematician, says, "All right, all right, all right." And he pours 2 pints on the bar. Everybody goes home happy. Ba-dum-tsh. If you don't understand that now, hopefully you will do in a couple of seconds' time. Here we're going to talk about geometric series. So we know that the sum for a geometric series is given as Sn is a lots of 1 minus r to the n all over 1 minus r. Now a special thing happens when that ratio between terms is caught between minus 1 and 1. Why? Because if I take a number between minus 1 and 1 and I multiply by itself, it gets smaller. If I find a third of a third, it's smaller than a third. And if I find a third of that, it's smaller again. So any value there that I would raise to the power of n would tend towards 0 as n tends towards infinity. So what does that mean for this infinite sum? So if I want to take the limit as n tends towards infinity of a lots of 1 minus r to the n all over 1 minus r, this becomes a lots of 1 minus 0, as was agreed on the right hand side, divided by 1 minus r, or simplified a over 1 minus r. So the infinite sum of a geometric series is the first term divided by 1 minus the common ratio, so long as that common ratio is stuck between minus 1 and 1. So back to our joke. First man was a pint, and half pint, quarter of a pint, so on, so on, so on. So here we have first term is 1. Common ratio is a half. What can we do with that information? Well, I'm looking for the infinite sum, which I know is given to me as a over 1 minus r. So in this specific case, that's going to be 1 over 1 minus a half. 1 minus a half is a half, so this gives me 2. 2 pints, cue applause, cue rolling on floor with laughter. The geometric series sums to 19 after 3 terms and has infinite sum 27. Find the value of r. So let's transfer this into language that we're happy with. The sum of the first 3 terms is 19 and the infinite sum is going to be 27. How do I work out the sum of the first 3 terms? Well, that's simply a lots of 1 minus r to the power of 3 all over 1 minus r, which is going to be 19. And my infinite sum is a minus 1 over r, which is 27. I'm just tidying up this so that we can see what it's actually trying to say. I can recognise that I've got a over 1 minus r in both cases. So if I write this out on the left hand side as 1 minus r lots of 1 minus r cubed is equal to 19. Hopefully we can see that we're going to make a nice little substitution here, because I already know that a over 1 minus r is 27. So another way of writing this would be to say that this is 27 lots of 1 minus r cubed, which is 19. Now expanding that is going to give me 27 minus 27r cubed is equal to 19, and rearranging this is going to give me 8 is equal to 27r cubed. 8 over 27 is equal to r cubed, and I can take the cube root of this to find out that r is going to be 2/3. As always with these sorts of things, what we should be looking to do is to use the terminology and the notation that we're confident with. So we're talking here about the sum of the third term, the first 3 terms, so we write that out. We're looking about the infinite sum, so we write that out. We use the information that we've got to try and solve our problem. And that's it.